Introduction. Hey kids, today we will learn water, hydrogen peroxide and heavy water. Water is a chemical substance and its chemical formula is H₂O. It is a colorless and transparent liquid. It contains one oxygen atom and two hydrogen atoms. Hydrogen peroxide is a combination of hydrogen and oxygen. Its chemical formula is H₂O₂. Heavy water is a deuterium oxide. It is another form of water which contains hydrogen deuterium isotope. So, throughout this module we will learn water, hydrogen peroxide and heavy. Objectives. At the end of this lesson, you will be able to discuss physical and chemical properties of water, discuss structure of ice and water, distinguish hard and soft water, explain the methods of preparation of hydrogen peroxide and discuss its physical and chemical properties, define heavy water and discuss dihydrogen as a fuel. Water. Water is most common, abundant and easily obtainable of all chemical compounds. It is a crucial compound for man's survival. It can exist in solid, liquid or gaseous forms. It is the universal solvent. 70% of our body contains water. 75% of Earth consists of water. Physical properties of water. It is colorless, odorless and tasteless liquid. The blue or bluish-green tint of water is due to its depth. Water's freezing point is 0 degrees Celsius and its boiling point is 100 degrees Celsius. When frozen, it expands by 1/9 of its original volume. The boiling point of water depends upon the pressure on its surface. The higher the pressure, the higher the boiling point. Structure of water. A water molecule consists of two hydrogen atoms and one oxygen atom. It has high polarity. The three atoms make an angle. The HOH angle is approximately 104.5 degrees. The center of each hydrogen atom is approximately 95.7 picometer from the center of the oxygen atom. As oxygen is more electronegative than hydrogen, the hydrogen atoms end up with a partial positive charge and the oxygen atom with a partial negative charge. This separation of charge produces a net dipole moment on the molecule. The solid form of water is ice and the density of ice is less than that of water. Structure of ice. Ice has three-dimensional network in which each oxygen atom is surrounded tetrahedrally by four other oxygen atoms at a distance of 276 picometer. Three-dimensional structure of ice has got an open space, that is why it has less density and floats over water. Chemical properties of water. Amphoteric nature. The ability of some chemicals act either as an acid or a base is called amphoterism. If a base like NH3 is present, water can act as an acid and react by donating a proton to that base. If an acid like H2S is present, water can act as base and react by accepting a proton from that acid. The self-ionization of water is another example of water being able to react either as an acid or a base. Redox reactions involving water. Dihydrogen can be produced by the reduction of water as given. Chemical properties of water. Hydrolysis reaction. The reaction of compounds with water to form new compounds is called hydrolysis. For example, dinitrogen pentoxide reacts with water to form nitric acid. Hydrates formation. Water form hydrates with metal salts. There are three main types. Coordinated complex compounds. For example, nickel 2 nitrate hexahydrate. Coordinate bond is formed between O of H₂O with metal ion. H bonded. For example, copper sulfate pentahydrate. Interstitial hydrates. Water is present in some compound as interstitial water. For example, BaCl. Hard and soft water. Hard water. The water which contains dissolved salts of Ca2+, Mg2+, and Fe2+ is called hard water. It does not form enough lather with soap. Soft water. It does not contain dissolved salt of calcium, magnesium, iron. It forms enough lather with soap. It is free from bicarbonates, sulfates, chlorides of Ca2+ and Mg2+. Fatty acids. Those acids which contain higher alkyl chain are called fatty acids. For example, C15H31COOH, C17H35COOH. Hard water forms precipitate on reacting with soap. Reaction of hard water with soap. Hard and soft water. Water hardness is of two types. Temporary hardness. It is caused by the presence of bicarbonate of calcium and magnesium that are, and it can be removed by boiling. Soluble bicarbonates change to carbonates which are insoluble and get precipitated. Clark's method. When calculated quantity of lime is put in, it causes precipitation of calcium carbonate. Permanent hardness. It is the hardness caused by the presence of chlorides and sulfates of Ca2+, Mg2+, and Fe2+. It can be removed by treatment with washing soda or sodium carbonate. Sodium carbonates converts calcium and magnesium salts to insoluble carbonates which can be filtered off. Calgon's method. It is sodium hexametaphosphate. The complex anion keeps the Mg2+ and Ca2+ ions in solution. Ion exchange method. Zeolite or hydrated sodium aluminium silicate is called permuted. NaAlSiO4 3H₂O is used to remove Ca2+ and Mg2+. The zeolite can be regenerated by treatment with NaCl solution. Synthetic resins method. Synthetic resins method. Hard water can be softened by using synthetic cation exchangers. They are more efficient than zeolite and permuted. These cation exchangers are large organic molecules containing sulfonic acid, RSO3H group. The ion exchange resin is first changed to the sodium form by treatment with NaCl solution and then used for softening of water. The resin can be regenerated for further use by treatment with NaCl solution. Hydrogen peroxide H₂O₂. Preparation. Hydrogen peroxide can be prepared by the action of sulfuric acid or phosphoric acid on hydrated barium peroxide. Anhydrous barium peroxide does not react readily with sulfuric acid because a coating of insoluble barium sulfate is formed on its surface which stops further action of the acid. Therefore, hydrated barium peroxide BaO2 8H₂O must be used. Industrially, it is prepared by the auto-oxidization of 2-alkylyl anthraquinols. When 2-ethyl anthraquinol is oxidized in the presence of hydrogen or palladium, it gives hydrogen peroxide. Physical properties. Hydrogen peroxide is a clear and colorless liquid. It has a slightly pungent odor. Hydrogen peroxide is a versatile and environmentally friendly chemical with a wide variety of applications. Structure. Hydrogen peroxide has a non-planar structure. In gas phase, dihedral angle is 111.5 degree. In solid phase, at 110 Kelvin, dihedral angle is 90.2 degree. Chemical properties. Hydrogen peroxide can act as oxidizing as well as reducing agent. Oxidizing action in acidic medium. Reducing action in acidic medium. Oxidizing action in basic medium. Reducing action in basic medium. Storage. Hydrogen peroxide should be stored in roofed, fireproof rooms where it can be kept cool and protected from direct sunlight. It is very important that hydrogen peroxide should be protected against all types of contamination. With proper storage in the original containers or in tank installations, the solutions can be stored for long periods without noticeable losses in active oxygen. Uses. It is used as an antiseptic and for mouthwash. It is used in chemicals manufacturing food, water and wastewater treatment. It is also used in biological sewage treatment in cases where there is a lack of oxygen due to overload of biological treatment plants. It is used in oxidation of formaldehydes, phenols, organic chlorine compounds, etc. Heavy water, D2O. Heavy water is the oxide of heavy hydrogen and is also called deuterium oxide. The credit of discovery of heavy water goes to Urey, who first proved that 6,000 parts of ordinary water contains about 1 part of heavy water. Demonstration of heavy water. Firstly, take 2 beakers filled with water. Drop an ice cube which is blue in color in the first beaker and see that ice floats on water. In another beaker, drop another ice cube which is red in color of heavy water D2O. You will see that the ice cube sinks in the water. This is due to the fact that deuterium is heavier isotope than hydrogen and it changes physical and chemical properties of water. Dihydrogen as a fuel. Hydrogen can be used as a source of energy. It involves the production of large quantities of hydrogen electrically and its storage in liquid form in vacuum-insulated cryogenic tanks and used in space programs. Hydrogen can be a future source of energy. Advantage of hydrogen as an automobile fuel. It produces greater energy per unit mass of fuel due to high calorific value. It is pollution-free. Combustion products of hydrogen in presence of air will be H₂O and traces of oxides of nitrogen. Internal combustion engines can be easily modified for use of hydrogen as a fuel. 5-point fuel cells generation of electric power with efficiency 70 to 85% have successfully operated commercially in space vehicles. Did you know? Hydrogen peroxide can be used to induce vomiting when a dog has ingested poison. Gold nanoparticles can be used to produce hydrogen fuel.
Summary.
Let us summarize what we have learned. Water is most common, abundant, and easily obtainable of all chemical compounds. The H₂OH angle is approximately 104.5 degrees. The center of each hydrogen atom is approximately 95.7 picometer from the center of the oxygen atom. Water has the ability to act either as an acid or a base is called amphoterism. The water which contains dissolved salts of Ca2+, Mg2+, and Fe2+ is called hard water. The water which does not contain dissolved salts of calcium, magnesium, iron, etc. is called soft water. It forms enough lather with soap. It is free from bicarbonates, sulfates, chlorides of Ca2+ and Mg2+. Temporary hardness can be removed by boiling and Clark's method. Permanent hardness can be removed by treatment with washing soda, Calgon's method, ion exchange method, and synthetic resins method. Hydrogen peroxide can be prepared by the action of sulfuric acid or phosphoric acid on hydrated barium peroxide. Hydrogen peroxide has a non-planar structure. Heavy water is the oxide of heavy hydrogen and is also called deuterium oxide.